we release, so lattice energy is the energy released when I make this nice, pretty little cube. Okay? So originally I've got all my metal cations, my non-metal anions, they're just kind of floating around. And that's not very stable, because if they're just floating around, you can get some of them next to each other. Like, look here, like these guys are right next to each other. These guys are right next to each other. We don't want positives next to positives and negatives next to negatives. So if they're just kind of like around each other, that's not kind of the best stable position. So what happens is that my cations start to become attracted to an anion, and they start to kind of come together to make this, make my structure. So you've got the cation and anion, cation, anion, cation, anion. Then you go up, cation, anion, cation, anion. And so if you notice, no matter if you go up or down or across or whatever, it's going to be positive, negative, positive, negative. So it's really balanced. And so by having them come together, it's going to separate my ions from being right next to each other. Okay? So here, they could be kind of next to each other. Here, we've got separation. So what happens is this energy is going to be released. So it's here, and then when I go from this craziness to my nice crystal lattice structure, then my energy is going to be released. It's released. Goes out into the environment, or the container of whatever the chemical is in. So if it releases energy, it's going to be more stable. So my crystal lattice is more stable. Now we can actually calculate this process, how much energy is going to be released, doing math. Now for you guys, you don't need to do that. We're not going to do any of this. All I want you to know is that this energy, that this little cube is more stable, and it's called the crystal lattice, and then it releases energy to become like this guy, and that's called lattice energy. How much of this energy is released depends on the size of the charges. Is this a +1 or a +2? And then also the distance between the ions. Are they really far apart? Then it's going to be hard to kind of get everybody organized versus are they close together or not. Alright, so let's move on and let's talk about some properties. So now we're going to talk about some properties of ionic compounds. Alright, so if it's a solid, ionic solids, they're brittle and hard. So you can think about salt. So remember, NaCl is kind of our example for our ionic compound. So brittle and hard. Think about a block of salt, kind of brittle, it's hard. Ionic compounds have high melting points and boiling points, so you have to heat them up a lot. So if you just put a bunch of salt in a pan, it's going to take a lot of heat before they're going to melt. All ionic compounds are solids at room temperature, so that's why my block of salt just chills as a solid. And the reason that this is so high is because if I want to melt, if I want to take my ionic solid, which would look like this, my crystal lattice, and I want to melt it, it's got to go this way. Oops. I have to break it apart and make it all crazy. It doesn't want to do that. Remember I said it wants to be in this nice cube. So to melt it, I have to put in a lot of energy to force it apart, to break it apart. So because those attractions between the ions are hard, to break down the crystal requires a lot of energy. Remember, a lot more than that lattice energy. So this is why I have such a high melting point, because it wants to stay together. Here's just kind of another picture. So this would be my NaCl, so you've got my positives and negatives and my nice crystal lattice. And then if I want to break it apart, so now it's not as nice and orderly, you could have some of the charges right next to each other. It's going to take a lot of heat. It takes a lot of heat to take my crystal lattice and break it apart. So that's why these melting points are so high. Alright, let's talk about some more properties. I'm actually going to talk about more properties on the next lecture, just to kind of keep these videos a little bit shorter. So we're going to talk about electricity conductivity on the next lecture.